I really don't remember. Did I derive the distance formula in 3-6 or not?
Yeah.
I did, okay. So I must have mentioned midpoint. I shouldn't say midpoint rule, I meant midpoint formula.
Yeah.
Okay. Yes, what does a graph look like? In the x, y, z coordinate system. Yeah, I think it looks like a plane, specifically the plane that's parallel to the xy coordinate plane, just hovering 3 units above the xy coordinate plane.
Is that even a 3D graph? That looks like a 2D.
Yes, that's a 2. X minus 2. Might be that bad today. Y minus 3. For those of you that don't
2D line.
don't worry, I type all your exams.
Maybe like an angle going like that.
No, I kind of like that. I think using the principle of zero products from Math D, I could say each of those factors equal to 0. And x being equal to 2 when I solve the first equation is just a plane parallel to the yz coordinate plane. And I think y equals 3 is another plane parallel to the xz coordinate plane. So question, am I looking at 2 planes that intersect, or am I looking at their intersection?
Intersection. Yeah, it's a line in 3 space.
Is it?
No, that's 2 planes.
How do you know?
Well, I mean, look at it as a 3-dimensional space where you march along both the x and y axis, because we're treating them both as independent variables in this case, right?
Yes.
So let's say, I mean, obviously, if we were to ignore the 2 and 3 right now and just look at the x and the y, anytime you were to march equal distances along, you would end up actually with this sort of parabola, because you're multiplying the x and the y. So if you were to march 1 up the x and 1 up the y, assuming z is vertically up, you'll go this distance where you'll get 1 times 1, but then you go 2 and you get 2 times 2, which is 4. So this 45-degree angle between the x and y will result in this sort of parabola, but as you skirt towards each axis, the parabola will morph down.
Now, I see what you're saying by using the word parabola, because I really
Well,
have...
yeah, it's similar, but that's just one limited.
But I think because the variables are different, it might look slightly different than suggested. I mean, let's get it. I'll come right back. I think that's a mystical graph. Because that would be a...
I know you would.
I was looking at you when I was writing, okay? It's not a lambda, it's an x.
It's going to be a bunch of
Now we have some like all staring at me. Now what does that look like?
That looks parabola.
parabola.
It's
Flat.
Well, I didn't see anything about z.
There's no z-plane, it's just going flat.
Oh, it's a plane shaped like a parabola. A plane where if you took cross sections of it.
I'm a little nervous because I tend to use the word plane to represent a flat
Okay.
item. By the way, it's interesting is that in mathematics, we can't define the word plane. It's one of our undefined terms, just like a line or a point in geometry. But you guys, I agree with that, because I think that this is the x-axis. Here's the y-axis. Here's the z-axis. I think if z is equal to 0, cheapers, the graph of that thing is what you guys graphed back at Math D. And I think y equals x squared in the xy coordinate plane simply looks like this thing in blue.
So you're graphing on the floor, right? Yeah.
Oh, but shoot, that equation doesn't say anything about z, so I guess z could be anything. So maybe I have this problem when z is equal to 0, or z equals 1, or z equals pi, or z equals negative e. And therefore, I think it becomes something different.
Well, wouldn't you just project it up to z?
Thank you. And so I think what I end up getting is like a trough.
Well,
Yeah.
infinite both ways, but yeah.
It just goes on indefinitely in both directions. I might even give that a name in the very near future. I might refer to this as Gosh, any ideas of what words I can use?
I don't know, paraboloid or something.
I think a paraboloid would be different. I think that would look more like this.
Oh, that's true. Well, I was just thinking like spheroids.
Looks like maybe half a cylinder.
See, I was hoping you'd say it is a cylinder. I know it goes on definitely in this direction, but it's just a collection of parallel lines. Good. So go back to part 2. I was not happy with your answers. Yes?
Well, my answer assumed that it was equal to z, how I answered it.
Gotcha. Okay, I can see that.
Yeah, that was my problem.
But now that you see it's equal to 0, I want you guys to answer my question, which was this. Is the graph of all points satisfying the second equation, is that going to constitute 2 intersecting planes or the intersection?
2 planes.
Why?
Because you can sort of separate those out into 2 different
That's the
planes.
key. I think you're saying everything. Blackhead. I think with that second equation, using the principle of zero products, I can proclaim that x minus 2 is equal to 0. Finish this up for me.
X equals 2. Y equals 3.
I disagree. Something else has to come first. I heard that. No, serious, that's the key word. The key word is or. Or that y minus 3 is equal to 0. Because when I use that disjunctive connector, I'm really saying I've got
Wait,
solutions to the first equation.
Didn't you say y minus 3 equals 0? Not y equals 3?
You're right, it means the same thing. I'd solve for y.
Oh, okay, okay.
But I think the key is that disjunctive connector, in English the word or, which in terms of sets means you're looking at the union of those 2 sets. And that's why I maintain, it's really because this principle of zero products, that what you're saying is correct. I really have both planes, collectively speaking. If I were looking at the intersection, I have to change this to the word and, which is not the case with the principle of zero products.
So are you really just setting a z equal to 0?
No, I'm not.
Space.
I'm really saying z could be anything in dermal, please.
Okay.
That's why this beast right here looks like the following. Y-axis, z-axis, x-axis coming straight up inkboard. I think this is a collection of all the points that are 2 units away from the yz coordinate plane. It's a plane that's floating here in the room that's 2 units away from the inkboard and in front of the inkboard. Makes sense? Yes, sir.
So just about the or, is it exclusive in that?
What a good question. I'm just using it the standard way I would in English, which is an inclusive, not an exclusive or. When he's using that adjective exclusive, he's saying this. Is it possible for both these to be satisfied simultaneously? The answer is yes. And sir, again, here's why. It's going back to the principle of zero products. If A and B represent real numbers and the product is 0, then either the first is equal to 0 or the second is equal to 0, and to address his issue, check out what would happen if both A and B were equal to 0. Is it still a true statement?
Yeah.
That's why I'm using the inclusive or as opposed to the exclusive or. That was a really good question. What can you guys say about this? X-axis, Y-axis, Z-axis. I've got some point, call it C, located at the X naught, Y naught, and Z naught. And in 3-dimensional space, I want you to walk away from that point. How about R units? And if I ask you to walk away from C, R units, where are you? Bless you. In words, make a full sentence in English. Where are you?
You're right.
That's from C.
True, true. That's good. Maybe I had a poor question. Let me rephrase that. Yes, sir.
Just make it sphere.
Thank you. So I think you're on a sphere whose radius is R, whose center is located X, not Y, not Z. Do you guys agree? Maybe I can try to draw that. Oh shoot, that's too poor. Looks like a circle. Maybe I can change it a little bit. So you, the reader, understand it's a sphere. And if the radius is R, do you guys think you could just sit in your chairs?
Was that a C in the center?
Yeah, that's why I chose the letter C. Can you sit in your chair without any writing and tell me what the equation of the sphere is?
That equals r.
Man, somebody's having fun.
That equals r, or is less than or equal to.
What is equal to it?
The point.
Oh, good point. No pun intended. I don't see the point. I'll make one up out of thin air. Here's one on the sphere. Quarters are X, Y, and Z. And let's label it as P. What can you say about the equation of the sphere? Where'd you get that? Where'd you get that? say you got that from last class, meaning the distance formula
Oh
in
yeah,
space.
it should be the square root of each of the components squared equals off.
Very nice. Since it's the case that the distance between any point P on the sphere and the center is going to be equal to the radius of the sphere, then using my nifty little formula from last time in class that I derived out of thin air, I just didn't slam on the board, I think we got the square root of the sums of the squares of the differences in their x coordinates, y coordinates, and z coordinates. And that's going to be equal to my radius. Oh shoot, that looks too sloppy. Can I take the square of both sides? And now I've formally given you a standard form for the equation of a sphere that lives in three-dimensional space. Looks just like the equation, the standard form for the equation of a circle you had back in Math B. Do you guys agree? If you do agree, consider this equation. Anybody?
Then you can just factor each of the individual terms, and then you'll have that.
What do you mean factor?
Okay, well you'll separate, you basically just rewrite it to have x next to x, y next to y, and z next to z, and then from there you would be able to find the center.
How? What's that? Oh, I like it.
Yeah,
Complete
complete the square and then just
So
there.
in completing the square on x with my blue pen, I will add the square of half the coefficient of x. Oh shoot, that's not legal. I better compensate.
Where did that subtracted 10 go from?
I'm just gonna put it in yet. It's just gonna be one of the more other constants I'm gonna have. Take it to the other side. I'll subtract 10 from both sides simultaneously. And with my red pen, how about if I complete the square on y? And if I complete the square on y, I'm adding 4 to the left-hand side, but I'll make it legal and add it to the right-hand side as well. And lastly, with my green pen, I will complete the square on z. Ah, shoot, you guys were, I said green. Oh well. Piece of cake. That being the case, I now have this first trinomial indeed equivalent to this perfect binomial square. Same thing with the next trinomial. Same with the third one. So humor me, where's the center? Well, that's the radius. The radius is 2. Where's the center?
3, -2, -1.
3, -2, -1. I agree. How about this? Anybody?
You just said variables equal to 0 and
I like that. Before we do that, to get the symbols of mathematical interpretation, can we just talk more generally? So everybody help me with this. How far away is the center of the sphere from the YZ coordinate plane?
3.
Yeah, I want you to try to picture that. It's 3 inches away. What's the radius? 2. So what do you think you can say intuitively about the intersection of the YZ coordinate plane with the sphere in 3 space?
Does not exist.
Yeah, I agree with that, because the center is more than the radius units away from the YZ coordinate plane. So for the YZ coordinate plane, I think there is no intersection. What do you think you could possibly say about the intersection of the sphere and the XZ coordinate plane? Is there an intersection? Good. The center's 2 units away from this coordinate plane, but the radius is 2. Therefore, the intersection is
Point.
a point. Can you give it to me?
Just hover from the center.
You just hover from the center, or how about taking the center and just projecting it onto the XZ coordinate plane? And I just think that you get the point whose location is going to be the center. It's just that I'm on the XZ coordinate plane, so the Y coordinate has to be 0. I agree.
In fancy terms, does that still count as an intersection, since it's?
Oh,
just
I
radius?
definitely, as a mathematician, would consider it an intersection. It's just that the intersection is a single point.
Okay.
What do you think you can say about my next question, Jensen? You know what it is. Well, no, it's not that one. How about this one?
XY.
Is there an intersection?
Yes.
Yeah, I think there is. Think about it, you guys. The center's located 1 unit away from the XY coordinate plane. That's the one that's flat down here, look on the floor. I'm 1 unit above it. Excuse me, I misspoke. My center's 1 unit below it, but the radius of the sphere is going to be 2 units, which means I do intersect that that XY coordinate plane. I just intersected that infinitely many points. Where are they? They're on a circle. What's the equation of a circle? I misspoke. How do you find the equation of the circle? Stop thinking. Be lazy.
Get the center and the radius of that circle, so. You gotta find the cross-section of the sphere at that Z coordinate.
But what's the z coordinate? What's the z coordinate of all the points in that circle?
You can
Minus
substitute it
1.
into the original.
See, I think z is going to be equal to 0. Because I'm looking at the intersecting sphere with the xy coordinate plane
Minus
down
1
here.
from the center of the
So
sphere.
I think all I have to do is plug 0 in for z. I'm done. And that gives me the equation of a circle, which is nothing more than x minus 3 squared plus y plus 2 squared. You guys are making me do all the work again. Which is nothing more than the circle whose center is located at 3, -2, and whose radius is √3.
Wait,
I will wait,
how did,
because I think everything I just said in English is wrong, even though I wrote things correctly.
how did you pick up the radius for that? I don't get.
All I did was this in my head. I just plugged 0 for z. That was
Uh-huh.
I subtracted from both sides.
Oh, okay.
You guys, listen to what I just said out loud in English. I said, look at that, it's a circle whose center is located at 3, -2, its radius is √3. Why is that wrong?
You didn't specify what z is.
Thank you. That's one thing that I did not do correctly. I did not specify the z is equal to 0. I think here's another mistake. I think what I just rattled off was a circle in 2-dimensional space. I thought I'm living in the XYZ coordinate system. So what I think this is, I think it's a circle in the XYZ coordinate system, but in the XY coordinate plane, whose center is located at 3, -2, 0, and whose radius is √3. I think there's another mistake with what I'm writing on the board, though, because when I see what I'm writing on the ink board, I'll dive into this more heavily next week or maybe the week after. I think, graphically speaking, what this represents is the circle we're talking about. But since I didn't tell you what z was, it's slid up and down. It's a cylinder that does not end in either direction. That's not what I want, is it? I just want the circle. So I have to tell you, the reader, specifically what z is. I have to say, here's my equation, and specifically z is equal to 0. Because if I don't stipulate that, I don't have a circle. I've got, like you just said, a cylinder going in both directions. Make sense? I'm just be careful.
Say the center again.
Yeah, I think the center of the circle. I think the center, being in the XY coordinate plane, is going to be located at 3, -2, 0. And the corresponding radius, of course, is going to be the square root of 3. You guys want to shake me up on this? Yes, sir.
I'm just curious, is that like a piecewise function that when you stipulate z equals
Yep.
0?
No, it really is much different than a piecewise defined function, because I'm not somehow restricting the domain of maybe some independent variable like t. Although, by the way, I will sometime this semester. Just not today.
Can you maybe quickly graph this so
Yes.
it's easier
quite
to
easy.
visualize?
So
Yeah.
just this portion right here in the
Yeah.
XY coordinate plane. You guys, here is the x-axis. Here's the y-axis. Here's the z-axis. Sorry, I've lost all my numbers. 3, -2. dot is the location of the center of my circle, and the YZ coordinate plane, that's on the inboard, excuse me, that's the flat line here. And I think since the radius is equal to the square root of 3, that was my red pen, I will draw a circle to the center, whose radius is root 3. I think it looks something like this. Would you guys agree? I don't think it's going to intersect the x-axis at all because, oh, this center is 2 units away from the x-axis, but the radius is only square root of 3, which is less than 2. So I think my picture's somewhat accurate.
Okay.
It's okay, you guys. Gosh, I can't believe the clock's doing that.
So without stipulating that z equals 0, we have this infinite.
Yeah, I think if I did not stipulate that z was equal to 0, I'm going to have the cylinder. Now, I'm doing a poor job, and so will you. You'll do a poor job as well by indicating to the reader that it goes on indefinitely both directions. I have a hard time doing that. In two space, it's easy in algebra. I got arrows at the end. But with these cylinders, these infinite cylinders, I don't have any kind of nice notation for that. So I'm assuming you, the reader, understand that it does not terminate upstairs or downstairs. Shoot, you guys, I haven't even mentioned vectors in 3 space. Let's do it. Got a name for this one?
X vector v1 half.
Well, no, specifically on the x-axis.
Oh.
Yeah, I think an I-bar, or you said I-cap, that's fine. Which has components.
0, 1, 1, 0, 0.
Or maybe we can talk about
J half. 0, 1, 0.
or maybe we can talk about very nice. Yes or no answer? Do you think any vector in 3-dimensional space can be expressed as a linear combination of these 3? Yeah, I think so. I'll even show you how. Specifically, I think an arbitrary vector in 3 space, I'll call it U-ball, whose components are A, B, and C. I think I can express this as the sum of these 3 vectors. Well, maybe not those 3, but these 3. Or how about if I take this one step further? From those 3 vectors, I'll pull out that constant, that scalar, A, B, and C specifically. And I think I'm left with A times this piece, plus B times this piece, plus C times this piece. Whoops. Or shall I say more concisely, I just got an A times I bar, plus B times J bar, plus C times K bar. Do you guys mind if I don't give simple examples like I did on Monday? Where I simply took a look at some specific vectors, I added together, pulled out coefficients, or multiplied by coefficients. All those operations remain the same in 3-dimensional space, just like they did in 2-dimensional space. How about if I say this? Jump into 4-dimensional space, or 5, or how about any n-dimensional space, as long as n is a finite real number, I'm going to get the same operations of addition and scale and multiplication. I think the only thing that might be a little tricky is just multiplication, whatever multiplication means of vectors. We'll get into it.
Of course, you're going to have to get more letters of the alphabet because you're going to run out of all the ways of describing your unit vectors.
You know what? That's a good point. And so when I jump into the n-dimensional space, I consider the unit vectors as such. I mean, that's the way I would typically refer to those standard unit vectors in n-dimensional space.
Is that an E? E1?
Yeah, those are E's.
E
E's.
to the N. I see some guys.
Oh, come on, that looks like an E.
Are you happy?
Now it looks like Pac-Man.
We've required a peanut gallery.
That's a mechanical device, not a geometric object. You guys, I'm not being careful with these numbers. I'm making them look out of thin air. I got a plane flies horizontally at 300 miles per hour, and it's flying due north with the wind. it blows into the direction. Oh, you guys, again, just making this up out of thin air. How about north? 20 degrees east. At, say, 50 miles per hour. And a downward flow of air. At, say, I don't know, how about 20 miles per hour? You guys, I'm not using very good English. When I say downward flow of air, I just mean there's a downdraft. So, question. What is the actual speed of the plane relative to an observer?
The speed or velocity?
How much is the speed on the ground? I like to use the word speed instead of velocity because now all you have to do is look at your vector theory, draw a pretty picture, and find the magnitude of the vector. That's why I'm choosing to use the word speed as opposed to velocity. Any ideas? How do you start? I asked. Yeah, draw a pretty picture. And if I draw a pretty picture, I guess I need an XYZ coordinate system. Oh, but shoot, you guys, I'm drawing an XYZ coordinate system, not labeling my axes, because I like to talk about directions. And I don't care how you guys deal with this. Personally, I'm lazy, I'm tired, I don't like to change things the way I had them back in Math B, so if you guys don't mind, I'm just going to think of the airplane traveling right on the XY coordinate plane. And I would just, for no other, just out of random, I'll choose one of the axes to point in a direction of north. Can I just choose a positive y-axis? And therefore the plane is traveling 300 miles per hour along the positive y-axis if I think of that as traveling straight north. Oh, can I label that? That's 300 miles per hour, isn't it? However, if that's traveling due north and traveling in the direction of north 20 degrees east, jeepers, where's that going to be my picture?
Well, that's north, that's east. Yeah, rotate from the y-axis 20 degrees towards the x-axis.
Very nice. And stay in the XY coordinate plane. I'll use his words. He said, point in direction north, but rotate 20 degrees towards the x-axis in the XY coordinate plane. All right, there I am. But I've lost it. What's the magnitude? I made these numbers up.
50 miles.
It's 50 miles per hour. And you said the angle was
20 degrees.
20 degrees. However, I also have a downward airflow at 20 miles per hour. That means I've got a third vector going straight down. By the way, you guys, that's not the vector. That's its magnitude. By the way, look at this symbol. That's supposed to be miles per hour, not degrees. No.
Yeah, same thing.
That being the case, the magnitude of the corresponding resultant vector is certainly going to give me the speed at which this plane is traveling relative to the observer on the ground. So let's draw the resultant vector in red. That's what it looks like. So let's give these vectors specific components. That's just the magnitude of this horizontal vector. Somebody give me the first vector. I'll call it v sub 1 bar. Somebody give me the first vector's components. Yes. I agree. As far as the components of this next green vector is concerned, I'll call it V2 bar.
50 times 20,
Say it one more time.
50 times 20 degrees.
So you're saying 50 sine of 20 degrees. What do you mean no? Why not? What's wrong with that?
Because that first thing, the x components should be cosine.
Oh, so you're saying with my dotted line right here, this is a duplication of the x-axis.
Uh-huh.
And if this is the y-axis, then technically speaking, shouldn't we be looking at this angle right here?
Right.
Which, by the way, has measure. Which has measure. 70 degrees. But I think the first component should be 50 times The cosine of the 70 degrees, do you guys agree? Now, technically speaking, there's nothing wrong with this really, because technically speaking, by the co-function identities, this is indeed equivalent to the cosine of 70 degrees. I just personally would write it as a cosine of 70 degrees. Not that this is wrong, it's not. Oh, I forgot, I changed my axes, or changed my colors. Again, I'm not erasing this because it's wrong. For me, I personally like to think of this as a cosine of 70 degrees. You guys, you're on a roll.
50 sine 70 degrees.
I like it. And lastly, in not in red, in blue. I'm running out of colors. In purple, I mean, this vector right here, I'll refer to as V3 bar. What are its components?
0, 0, 20.
Say it again.
Negative 20.
That'd be the case, I think in red. My red vector, I'll call it V bar. Simply has components that are the components of the three vectors in color. Would that give me, is it only 50? Cosine of 70? My second component is merely a 300 plus 50 times the sine of 70. And lastly, my third component is merely a negative 20. Shoot, you guys, I just goofed up. I didn't answer my own question. How do I answer the question? Compute the magnitude by doing the same thing we did back in space. Because I think the magnitude of this vector is merely going to be the square root of the sum of its individual components. Do you guys mind if I don't finish? I mean, at least that's the exact value. You guys agree? So jumping in the higher dimensional space is a piece of cake, isn't it? I just added one more component, nothing more.
This becomes difficult to visualize.
You know, it may become difficult to draw because I'm drawing in 2 space, but I think in visualizing it's not that bad in your mind because you can visualize in 3 space. And I've got the restriction of drawing on a 2-dimensional plane.
No, I'm just saying past 3 it becomes difficult.
Oh, past 3.
Yeah.
Yeah, I think that's why a lot of people would insist that the 3rd-dimensional plane is non-spatial because it's difficult to see.
Wait, that okay, I thought you said that the 3rd dimension.
Did I say 3rd?
Yeah.
I meant beyond the 3rd dimension. Many people consider those dimensions non-spatial, so they don't have to worry about the visual interpretation.
Well, you could do it maybe
Is-
if you were assigning something else to the fourth, something understandable fourth dimension like temperature in the room.
Yes,
Yeah.
absolutely.
Then you could easily.
But don't take it the wrong way, you guys. I'm not one of those people. I have no problem talking about objects in the higher dimensional space where all components are spatial. I'm just saying some people don't.
How would you think about it?
You worry about your limitations.
Yeah, how you think of it would limit how it actually works, right?
You guys ever read Flatman?
Yeah.
Heard of it,
You've
yes.
heard of it.
Heard of the premise.
Flatman.
Mr. A square of Lyman. The sphere.
It's not a show. There's a couple of these out there. Make sure you don't see them. They're horrible. They're horrible. I'm so sorry.
I was reading this book by this physicist guy, Shikoku, and he was talking about how beings in lower dimensional space can't really see the beings in higher dimensional space. And the other thing he was talking about was that you can for example, you know how so for Mario, for example, Mario has to go move in 2D space up and down all these obstacles.
Oh, that's a game, isn't it?
Yeah.
While you in 3D space can just ignore all those obstacles
Yeah.
and just go to the end.
Yeah, I agree. It's sort of like this. In 60 seconds, if I'm a square living on my tabletop, I'm only a 2-dimensional creature. And, sorry, somebody else is a square, not me. I'm a sphere, and I'm really bored. And I want to hover above here, above the square. And relative to the square, what do I look like? Good. It doesn't see me. I don't exist as far as he's concerned because I live out of this dimension. As a sphere, I'm a 3-dimensional creature. The square's only 2 dimensions. You can't look up or down. So as far as the square is concerned, I don't exist. It can't perceive my existence. So when you ask how do you deal with looking at the 4-dimensional space, I look at how I have a restriction of viewing what a 4-dimensional object looks like. Now I can do this. Look at the square down here. I can really mess with his mind. As a sphere by just popping in and just touching his universe. And if I touch his universe relative to him, what do I look like?
Looks like something that's serialized out of nowhere.
Exactly. And as I pass through his universe and go to the other side, my dot grows to a bigger and bigger circle, then smaller and smaller, and poof, vanishes out of thin air, as far as that square is concerned. And so maybe what you and I can do as mere three-dimensional creatures is you and I can look at three-dimensional cross-section slices of four-dimensional objects. But you know what? This is the year 2013. I got a computer. I can do this piece of cake.
So do we know of any four-dimensional objects that actually exist?
Yeah, there's one in my office on the shelf. Just take it, put it to peek in my window.
Like naturally occurring, not as a construct that we've made up.
I think all geometric figures are natural.
In Berkeley, they tried to create a crystalline structure in 4 dimensions,
Okay.
and I don't think they succeeded.
But it's not like we've been able to like look out into space or anything and look at something and say, gee, this might be the cross-section of something bigger.
Well, it wouldn't actually be bigger.
Or,
That's a
but have we been able to like observe anything like that in the natural universe, or is this?
How do you know we're not looking at them all the time? I mean, when you look across the universe, I mean, are we really looking at an XYZ coordinate system, or is it warped in some other fashion? Which means you might be looking through another dimension. You guys check this out real quick. I don't know if I can. I don't know where this is. Oh, here I go.
Okay.
Here's a 4-dimensional surface coming in and out of a 3-dimensional space. I've got actually a 5th variable attached to this, namely time, so you can see how things are changing. But there's an example of what's going on for you and I in 3 space with a 4-dimensional object passing through our universe, which I can describe mathematically, absolute piece of cake. That's why I can write these equations.
So is this a four-dimensional cube?
It's a 4-dimensional surface.
But we don't know what shape it is.
You would if you were able to look at the equations. I'd have to look at the equations.
Oh.
Will we actually go beyond 3 dimensions in this class? Yeah.
But we won't draw.
But
Okay.
the cross-section in our 3 space looks roughly like a cube.
Okay.
Yeah.
Yeah. I agree.
Okay.
So you guys, what do I have? How about section 11.2? Can you take a peek at these? Let me know how they go.
Mr. Balga,
Yes, sir.
make an announcement about the video.
Oh, what? So hold on, you guys, 1 second.
Can we make a video announcement?
Yes, please.
Because we actually didn't do that for this class yet.
No, we haven't.
Okay.
If you guys are interested, I don't know how you feel about this. You can let me know how you feel about it. But Brad is videoing the lectures in case you want to review them. He's done this in the past. And if you want to check out Brad, I'm in trouble.
It's Brad Morton on YouTube.
But what's the second last letter?
Owen.
Owen, got it.
Yep.
If you're interested on YouTube. And if you got a problem with that, please feel comfortable and talk to me and let me know.
Okay.
I don't mind discussing it. Oh, something else. I'm so sorry.
Yeah, no problem, man.
You guys